So again, even the last video ended unexpectedly because I lost the track of time again. I'm a human, I can't do that. Now, where were we? I've already explained this code 3 times, I'll have to do it again. Where were we? So, I think over here, yes. So I told you d minimum is equals to dis c. So what, so I'll start from here again. So if c equals 1, so for the first iteration of the loop, this will run and the first value of dist c will be stored in d minimum. So just, I want you to understand that's the code from here to here. From there to there, it's just trying to store the minimum most value of dist c in d minimum. Okay, just think about that sentence once more. The minimum value of dist c in d minimum. Now I think you will understand this if loop. So, if statement. So if c equals 1, d minimum is equals to dist c, else d minimum is equals to minimum of dist c comma d minimum. Already a value must be there in d minimum. It will compare it with the next value, and whichever is the minimum will be stored in d minimum. Now, after this if statement, what we are going to do, I don't know why we are doing this, but what we are going to do is, if d minimum is equals to dist c, if the minimum most value stored in d minimum is equal to the current value of dist c that you are getting over here, then you put that corresponding value of c in detect v. And after this if statement, after this for loop, when this for loop ends, what you do is, if data b is not equals to detect b, then you just increment the error counter. Already told you there is an error counter, error is equals to 0, you are incremented that error counter. So at the end of this code, at the end of, already told you, at the end of this for loop, you'll have the error of all the n 1000, n is equals to 1000 words. So now bit error rate is nothing but, oh, I didn't see that. I have my capture video, okay, over here itself. Now, no, I'll not do it again. Okay, fine, I don't know. Okay, I'll just minimize it. Now, so BER is equals to error rate by n. So sorry, total error by n. So this will give you the error rate. Now what we are going to do is simply SNRDB is equals to 1 to 21. Again, the same thing we are defining again. Figure 2, semi-logy. I don't know what the fuck is this. Okay, it's written right over here. It's a semilog scale plot, semilog graph. So we are plotting it, plotting a semilog graph of SNR in DB versus BER, and this one is nothing but the legend, I guess, which we can confirm right away. Is it the legend? Yes. No, these are not the legend. Those are the markers. So data markers, not the legend. After that, we just switch on the grid and X label, Y label, and the title. That's it. That's the QAM. That is it. Now the only difference between 4 QAM and 16 QAM is that over here you put 16 instead of 4, and you take the same number of days. Okay, it's 10,000. So I've been wrong the whole time. So it's 10,000, not 1,000. So after that, what? Okay, over here the map will be consisting of 16 points instead of 4 points. It will have 16 points. Just refer to the manual, and that is it.